Hello and welcome. The first lesson that we're actually going to start off with today is why it's important to pay attention to your teachers. So first is that many of us have eyes in the back of our heads. Second is that we have so much knowledge that many of us have the power of telekinesis. Ooh, a Greek and Latin root there. So we've got tele meaning distant and kinesis coming from kina, meaning to move, so we can move things from a distance. Pretty neat stuff, right? It's almost like there was like a ray of energy coming from my mind. And you know what? That brings up something really cool, because we're actually going to be talking about arrays today, but not that kind of array. We're talking about a multiplication array. But before we get started, we want to take a step back and really check to see what our strategies are on some of our addition techniques. So today we're going to start off by looking at 9 plus 7. So 9 plus 7, and then we're going to do 5 plus 8. So I want to give you a second to pause and see if you can't figure out the strategies for 9 plus 7 and 5 plus 8. Alright, so we talked about some strategies in class today, but today we really want to look on consolidating these two numbers into one group of 10 plus whatever is left over. So I'm going to take a moment here to draw down all the dots that are associated with 9. So we got 8 and 9. So we're 1 away from 10 there. Then we've got 1, 2, 3, 4, 5, 6, 7 dots here. So really what I want to do here first is move this dot over here to the 9, and we're actually, by doing that, we're creating a new problem. But because this is addition, it's all going to be combined anyway, and it's going to work out in the end. So as long as we're careful, let's see how this works out. So now that we've moved the dot over, we're not going to have 9 plus 7 anymore. We are going to actually have 10 plus 1, 2, 3, 4, 5, 6. Because there's nothing in our ones place and we're only adding 6 ones, so we're not going to change the tens place at all, we're going to end up with the answer of 16. So let's go back and check that, because it's good to do that whenever possible. And, oh, look at that. We're brilliant. Alright, moving on. I want to see if you can use that same strategy for 8 plus 5. So, I'm going to give you a second to do that. So, what we're going to do here is we're just going to take the 2 from the 5 to make the 8 10, and then we will end up with this new equation, which is 3 plus 10. Now we're adding 3 ones to the tens place, so we're not changing, or to the ones place, so we're not changing the tens place. 10 place stays the same. We add 3 to that 0, giving us 13. So let's go back and check our answer. Oh, shucks, we are so smart, aren't we? Alright, so we're going to move on here to our new thing, which is going to be arrays and grouping numbers to help us understand multiplication. So the first thing we should do in any word problem like this is read the directions thoroughly. It says solve and include sketches to show your thinking. Ellie bought 3 packs of stickers. There are 6 stickers in each pack. How many stickers did Ellie buy in all? So there are a couple important parts here that we really want to isolate, and I want to see if you can pause and pick out what those parts are. So what's really important here, I think, is what we have in terms of our packs and number of stickers in each pack. So we have 3 packs of stickers, so that's a really important thing to keep an eye on. And then we also have 6 stickers in each pack. So they are also asking us how many in all. So that's meaning all together. So we got to keep in mind we've got 3 packs of stickers and there are 6 in each pack. So we go over here. We are going to draw 3 packs of stickers to start off. And then because there are 6 in each pack, I'm just going to draw 6 circles in each pack. So we have a couple of different ways we can look at it. So we've got 6 stickers in each pack, and we're trying to find out how many there are in all. So that's really just repeated addition. So if we know 6 plus 6 is 12, and 12 plus 6 is 18, we'll know that we'll have 18 stickers in all. But this is another really cool thing. So this is where multiplication makes things easier, especially if you're multiplying things like 9 or 10 times in a row. You don't want to be repeatedly adding all of those numbers up and writing all of that out. So we have 6 1, 2, 3 times. So 6 times 3 is 18. Now, here's what I want to challenge you. I want to see if we can figure out if there were 6 packs of stickers and there were only 3 stickers in each pack. What would that look like? So I want you to try and do that on a scratch sheet of paper right now. Hopefully you've had a second to pause, and now we're looking at the flip side of things. We're thinking now, what if we had 6 packs of stickers, 3, 4, 5, and 6, but they were much smaller packs. They only had 3 in each pack. So we're going to add our 3 in each pack. Now we have a new addition problem, which would be 3 plus 3 plus 3 plus 3 plus 3 plus 3. Wow, that's a lot of writing out. So if we know 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15, and 15 plus 3 is 18. So that's going to equal 18. Or we could look at it just like this. We have the number 3. How many times? 1, 2, 3, 4, 5, 6. 6 times. 3 times 6 is 18. So you can do repeated addition, or you can do multiplication. It's just kind of a shortcut for us in that respect. And we also notice that it really doesn't matter which place it's in, because it's a lot like addition. 4 plus 6 will equal 10, and 6 plus 4 will equal 10. It's called the commutative property of addition and of multiplication. The numbers don't have to be in a certain place like they need to be in subtraction or division. So, moving on, we are going to look at our next problem here together, and I'm going to pause while I set that up. So our next problem we're still going to solve and include sketches to show our thinking, but this one's a little different. It says Max keeps his baseballs in a rectangular box. The box fits 4 rows of baseballs with 5 balls in each row. How many baseballs can Max fit into his box? So what I want you to do is pause and see if you can't pick out the really important pieces of information in this problem. Alright, hopefully you've had a second to pause and think about this problem. And really the important pieces of information we got are 4 rows of baseballs and 5 balls in each row. So we're going to take a look over here. And we're going to draw our baseball. So we've got 1, 2, 3, 4. So that represents our 4 rows. And in each row we have 5 baseballs. 1, 2, 3, 4, 5. 1, 3, 5. 1, 3, 4, 5. 3, 4, 5. So what we have just made actually is an array. An array actually beautifully explains multiplication. So we have 4 rows, and in each row we have 5 baseballs. So 4 times 5 is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. 4 times 5 is going to equal 20. Alright, hopefully this video has been helpful and informative and allowed you to make arrays to your heart's content, and hopefully gave you a little bit deeper understanding of how multiplication works. We will see you next time on Mr. Fletchstrom's Fantastic Formula.